Suppose theta is in quadrant 3 and also cosine theta is negative 2 over 5. Then find the values of the 5 other trig functions. Now, the knowledge that you need to have in order to solve this question is first the fact that sine theta squared plus cosine theta squared is 1. And another thing that you have to know is this: all students take calculus, meaning that in quadrant 3, tangent theta is positive, whereas cosine theta and sine theta are negative. Okay. Now, I want to show you two methods in solving this. One method is just simply applying this. And another method, you can use the triangle, which should be the preferred method because it's more general. The other method that I'm going to show you after this first one applies even if the given trig function is not just cosine or sine, but even if it's tangent or some other ones. Okay. So how do you solve this? Solution. You need to plug in this value in here. So sine theta squared plus negative 2 over 5 squared is equal to 1. Sine theta is therefore, sine theta squared is therefore 1 minus, well, negative 2 squared is positive 4, 5 squared is 25, so this really gives you 4 over 25, but since you've moved it to the other side, it'd be 4 over 25 subtracted. And that's going to be 25 minus 4, that's 21 over 25. And therefore, sine of theta would be plus or minus square root of 21 over 25. And then you have plus or minus. Square root of 21 is just square root of 21. You can't do anything, but square root of 25 is 5. So that's what you get for the sine theta. But which one do we pick? Do we choose the positive or negative? Well, we already said that theta is in quadrant 3. In quadrant 3, sine is negative, so we have to choose sine theta equal to negative radical 21 over 5. Because theta is in quadrant 3. Okay. Once you get the sine value, then you can get the tangent by using sine theta over cosine, which is negative square root of 21 divided by 5, negative 2 divided by 5, 5 cancels, and you get square root of 21 over 2. Alright. So we got the tangent, cosine, and sine so far. What we need is secant. Okay, so what's secant of theta? That's 1 over cosine theta. So you take the reciprocal of this, you flip the fraction, you get negative 5 over 2. Cosecant theta is 1 over sine, so you have to take the reciprocal of this, which is negative 5 over square root of 21. But you should rationalize the denominator, and you get negative 5 square root of 21 over 21. And then finally, cotangent is 1 over tangent. So you take the reciprocal of this, which is 2 over square root of 21, multiplied by square root of 21 top and bottom. So that's what you get. Okay, so these are the answers. Let me just circle the answers. So circle this one, this one, this one, this one, and this one. Okay, so those are the 5 answers. Now the second method, I don't want to do everything. I just want to show you how to begin. So what you want to do is you draw a triangle. Draw a triangle. And choose an angle theta, it's 90 degrees, and use Sohcahtoa. And according to this, cosine is adjacent over hypotenuse. So since this is 2 over 5, negative 2 over 5, we're going to ignore the sine because we can figure out the sine later by using the fact that it's in quadrant 3, right? So we're just going to think of adjacent as 2. This is adjacent. Hypotenuse is 5. And just put this as x and figure out x by using the Pythagorean theorem. 2 squared plus x squared is equal to 5 squared. So x squared is 25 minus 4 is 21. So we get x equals to plus or minus square root of 21. Just take the positive one. So we have the following picture. 2, 5, square root of 21. And here's the angle theta. Now, from this, you can figure out the sine of theta by taking Sohcahtoa again. Sohcahtoa says sine is opposite over hypotenuse. So opposite is square root of 21. Hypotenuse is 5. Done. Okay. And from this, you can determine that the actual answer to sine theta is minus square root of 21 over 5. Where did this minus come from? Well, it's from the fact that we're in the third quadrant. In the third quadrant, all students take calculus as only tangent is positive, sine and cosine should be both negative. So you can get sine theta equals to negative square root of 21 over 5. And the nice thing about this method is your tangent is now slightly easier than before because tangent is opposite over adjacent, so it's simply square root of 21 over 2. So you don't have to deal with complex fractions. And remember, tangent is positive, so we leave it as this. So we get the sine, we get the tangent, and you get all the other secant, cosecant, and cotangent just by taking the reciprocal as before. So this is the other method, and often this will give you the answer much quicker. What is the domain of and range of sine inverse of x? Okay, well, I can just simply give you the domain and range and simply tell you to memorize it. But let me add some explanation of what this question is about. So first, sine graph looks like the following. It starts from 0, goes to 1, 0, negative 1, and 0. Okay. So that's the graph. But this graph itself doesn't have an inverse because sine of x does not pass horizontal line test. Okay. And therefore, instead what you want to do is you want to take the portion of the graph from pi over 2 to 0, and then also remember that the sine graph is extended left and right infinitely, so there's also the left part, and because of the pointwise symmetry, it's going to end up at negative pi over 2. And here's what we get. We get that sine of x restricted to domain equals to negative pi over 2 and positive pi over 2 does pass horizontal line test. And what that means is that if you restrict the sine function to this domain, the minimum and maximum values are negative 1 and 1. And this does pass the horizontal line test. That means I can define an inverse function. So sine inverse of x is really not the inverse function of the regular sine function. It's really the inverse function of the restricted sine function. Okay, and because sine of x restricted to negative pi over 2 to pi over 2 has the range from -1 to +1, that means that the sine inverse of x, remember when you take the inverse function, domain and range flips, so your domain will be -1, 1, and range would be -π/2 to +π/2. So that's the answer. Answer to part A would be this. Okay. Now, in part B, the question is sine inverse of 5. Does this have a value? Well, you can try to calculate this using your calculator, and you'll immediately see that your calculator refuses to give an answer for this. And the reason is this 5 is outside the domain, right? So doesn't exist or is undefined because 5 is outside the domain of sine inverse of x, which is d equals to -1, 1. Okay, so that's why you can't do sine inverse of 5. And that was simple. Alright, last question is very simple. It's about Sohcahtoa. And since there's this missing part, you should really put that as x and figure out what x is. 3 squared plus x squared equals to 7 squared. Gives you 9 plus x squared equals to 49. Remember the Pythagorean theorem? And that says x squared is 40. That means x is equal to square root of 40. It can't be negative. Usually when you take away the square, you should put plus or minus, right? Can't be negative. And then if you take the 4 out, that becomes 2, so it's 2 radical 10. Okay. Now, the length, the side opposite of the hypotenuse is, opposite of the 90 degrees is called hypotenuse, so this is really the hypotenuse. And once you choose an angle, the leg that is right next to it is called the adjacent, and this one is called the opposite, because it's the opposite of the angle. And since cosine, according to Sohcahtoa, cosine is adjacent over hypotenuse, and therefore adjacent is 3, hypotenuse is 7, so that's what you get. For the sine, you get the opposite over hypotenuse, which is 2 radical 10 is the opposite, hypotenuse is 7, so that's what you get. And the tangent is according to Toa, is opposite over adjacent. So this is 2 radical 10 divided by 3, and that's it. So that was a simple question.